apply our log laws, the ones that we learned in the previous set of notes. We're going to apply these in different contexts, and we're going to apply these where these are bases are not always a nice base or base 10 or even a numerical base. So we need to make sure that we're comfortable applying these and understanding what a log is and how that log is defined. So here we have two logs, base b. So what we want to do first make sure is that the bases are in fact compatible. Here we have compatible bases. Okay, so no problem. Looks all good. So how am I going to simplify this? Well, I can use some log properties. I have multiplication, so I just need to combine these by, so I have addition of logs, so that means I'm going to multiply those together. And again, the condition of that the bases are the same. Okay, so I'm going to combine these. So I'm going to make this 8b cubed times 27b cubed. Okay, and I'm going to put that all together in one argument. Okay, put the square bracket. So that's all one argument. That's all pretty good. 8 times 27. Okay, that's going to be, what's that going to be? I think that's 200 and, what's that? 216, if I'm not mistaken. 216. So we're going to make this into, let's see here, log base b of 216, and that's going to be b to the power 6. Now what is implied is if you have a base b and you have base b numbers inside the log, those should be evaluated. Okay, so what's going to happen here is I'm going to split this up again. This is going to be log base b of 216, and I need to evaluate that as plus log base b of 6, which is just going to be 6. Okay, so we are kind of expected to, if you have a base here that matches, we need to actually evaluate that log, so we can evaluate these logs, the value of these logs. So here, this is a base A, so I want to combine these logs. To do this, I have to make sure that these coefficients are actually applied back into us. So we're going to use our exponent property to bring them back in, and then we're going to use our add and subtract properties to times and divide these logs. So that's the first thing I'm going to do. I'm going to apply this exponent back in. Now this exponent has to apply to the whole argument. Okay, we're safe here because that is all one part of the argument. Here, this is a little bit trickier and you have to be a little bit more careful. You can apply it separately like that power back into the log, or we can just group that whole argument and make sure that that power is applied to that whole argument in that way. Okay, so here we're going to end up with, and notice that we have base A, so that part has to be separated out and evaluated. We have base A here, so log base A of AC. Okay, so one way to do this is logs are exponents, so positive exponents are in the numerator, negative exponents are positive exponents in the numerator, so positive logs go in the numerator, negative exponents are in the denominator, and negative logs are negative exponents. So here I have numerator, denominator, numerator. Log base A, common base, I can write this as 3A all to the power 6. I'm just going to separate that power because I'm going to have to evaluate that. That's going to be times. I've got AC, that's times. That's going to be in the denominator. So cubed. Okay. I don't really need to separate that out. I think I'm just going to keep that together because none of that's going to simplify. So 4b cubed. Okay, I'm going to rewrite this as log base A, 3 to the power 6, A to the power 7, C all over 4b cubed. Okay, that's pretty good, except we just have to again remember that if we have a base A in the argument, a base A log, we really should evaluate that numerical value because we can. So this becomes log base A 3 to the power 6 C 4b cubed plus log base A of A to the 7 is going to be 7. So there's my final answer here. This one here is multiplying logs. Well, there are no laws for multiplying logs, so we have to be very careful. We do have some rules, algebraic rules that apply if we're just talking about the log values, but there's nothing that we can do with arguments for multiplying logs. Okay, so what can we do here? So I can't just do this. Oh, bases are the same. I'm going to multiply and say, yeah, that's good. Okay, no, this is wrong. We aren't allowed to do that. We can't. There's no law that says we can multiply. Any law for multiplying logs has anything to do with the arguments. Okay, so we can't do that. So we need to look for something different. Well, something different here is that, well, yeah, I got my base A. I can evaluate this as using an identity. This just becomes 2. Okay, I have a base A here. In fact, this is a square root and I have a 2 out front, so I'm just going to leave it like that for now because I can actually apply that power back into the log. So that's a power 2 on a square root. That just becomes 5a. And then I can evaluate the a part of this log. So this becomes plus log a of a. Again, this just ends up being 1. Okay, so there it is. I've evaluated that log. This one here is solve. So we have to be very careful because we have to remember that there are extraneous solutions. We also have to say that a must be greater than 0 and a not equal to 1. Okay, we probably should have done that here because that's a base. But since we're solving this, we are not going to solve for a, we're going to solve for x. So this may be a moot point. But to solve this, we need to combine. Okay, so I'm going to get log base a of x plus 4. I'm going to combine the plus logs. So adding logs means we multiplied our arguments. Okay, so there's one big argument now. I'm going to apply the log inside here. The log rule exponent goes onto the inside the argument. And then I'm going to make this a logical argument that if the logs or exponents are equal and the bases are equal, then the arguments or answers should be equal. So I'm going to drop my logs, and in fact I'm going to multiply this out. I get x squared minus 16, and that's equal to 9. Okay, and solving this, I can just go x squared equals 25, and then solve for x equals plus minus 5. Now there are extraneous solutions here because we have restrictions on x, because arguments cannot be negative. So when I plug this back in, if I test our negative x, or negative 5, okay, if I plug negative 5 back into here, I get log of a negative number. Here I get log of a, that's not possible. We cannot have negative arguments. So this is an extraneous solution. That's an extraneous solution. Okay, so when I plug 5 back into the original equation, positive, that's all good. So that's our good solution for this equation.